Hello students, good evening all. So welcome back to our next session of chapter Permutations and Combinations. So far we have already finished 5 sessions on this particular chapter. So today it will be the 6th session. So let's first we'll just have a quick recap like what and all topics that we have covered in our previous session, because there might be some continuations followed by in this session. So that's why we'll just have a recall from our previous session, and we'll just have a look that what and all topics, what and all concepts that we are going to cover in our today's session of permutations and combinations. So in our previous sessions, we mostly discussed about combinations. So we have discussed comparison between permutations and combinations. We have discussed some properties related to combinations. So mostly we have talked about combinations, so properties of combinations, and then we have already discussed the combination under restriction. Right, so that in this restriction conditions for combinations, we have covered when some p particular objects included. So mostly we have covered when p particular objects are excluded, and the other will be when p particular objects will be included in the combination. So for these two different cases, we have seen the formulas related to the each of the restriction, right? So we have even dealt questions related to this inclusion concept as well as the exclusion concept of some p particular objects. So coming into our today's session, we are going to discuss something different. So that is division into groups. Right, so how we'll be dividing into groups. So we'll be discussing the corresponding formulas and the conditions related to this. And we are going to see the questions also related to this division into groups. So this division into group is a special topic when it comes to our JE. So that's why. So it will be a special topic. So after this, the most important one in our permutations, that is a circular permutation. Right. So the next topic that we are going to cover here is a circular permutations. Right. So the basic difference here for a permutation and a circular permutation is when we talk about a general permutation, we'll be taking that in a straight line. So in a standard line. Whereas as the name itself, we can say that the permutations here will be considered in a circular format. So it's obvious that there will be a difference amongst this regular permutation as well as the circular permutation. So we are here going to see. So like in our general permutation, the formula which we apply is nothing but for n objects, if we take all at a time, so the number of permutations will be n factorial. So for the same thing, if the permutation there is a circular, what will be the difference? So how we will be seeing that and what will be the corresponding formula there? So that and all we are going to cover here. We are going to discuss in detail for circular permutations, right? And after these circular permutations, there are few concepts which are considered for our mains level. So for our JEE concept, so the first one here is sum of numbers. So we know if we have a number 12, so the sum of digits, it can be possible, or else we can take there are few numbers and we have to do the sum of unit digit, right? So likewise we'll be seeing here sum of numbers. So without having this simple addition and all, if we are having a formula, how we'll be directly doing it. So for that sum of numbers, we are having different cases, and for each of the case we are having our formulas, so we can apply directly in order to get the result, right? So apart from this sum of numbers, we even have formula for our factor of natural numbers, or we can say factorial of our natural numbers. So we guys are already aware of what is natural number and all. We know the basic representation of natural number. So how we'll be doing the thing? So here for this case also we are having the formula. So we just going to apply the formula and we are going to get the result. Right. So these are the concepts that we are going to cover in our today's session of permutations and combinations. So first, as we end up our previous session with combination under restriction, So today's session we are going to begin with this division into groups. So the first one we are having here is the number of ways in which m plus n different objects. So here we are having a group. So this group contains two different objects. That means m kind of objects and n kind of objects. Right. So m plus n will be our total objects. Right. So the number of ways in which this m plus n different objects can be divided into two unequal groups. So these objects must be divided into two groups, and the other condition is, so first condition is we have to divide into two groups and the groups should be unequal. Right. So containing m and n objects. So we are having m and n objects. So the total objects here will be m plus n. So amongst this m plus n objects, we have to divide into two unequal groups. So that is nothing but how many ways we can actually divide that. So here they are not asking that what is the group and all, but so here they are not asking us to find out the groups here. So here they are mentioning us to in number of ways, in how many number of ways we can actually divide that. Right. So that is given by our group factorial, that is our total number of group, that is m plus n objects factorial by. So we have to divide into two as we are having two different. So it will be m factorial into n factorial. So these number of ways, so this is not exactly the group of objects, but this is the number of ways how we can divide into two unequal groups here. Right. So you have to be pay attention here because we are talking about the number of ways of division, not the groups here. Right. So the number of ways of dividing will be m plus n factorial by m factorial into n factorial. Right. So what if we are having both m and n are same? Right. So if these both groups, that is initially we are having objects m plus n, but now here we are having both m and n are equal. That means m will be equal to n. Right. So if m equal to n, the groups are equal. Right. So in this case, the number of division will be, so in our previous, what it will be, m plus n factorial divided by m factorial into n factorial. So first thing is, in place of m also we are having n. So let's just replace that. So now it will become n plus n factorial and n factorial and n factorial, which is 2n factorial by n factorial and n factorial. But here as m and n are same, we will be having same groups. So that's why we have to divide it by 2 factorial, that means divided by 2. So as it is possible to interchange the groups without obtaining a new distribution. So that's why, so that's the only difference. We'll be dividing by 2 as we'll be having a two different ones. So that's why, so same ones. So that's why we'll be dividing by 2 so that we can get our without any disturbance. Right. So here when two groups are equal, then the number of ways here will be 2n factorial by n factorial into n factorial divided by 2. Right. So the why we are dividing here 2 is, so initially it can be start with m or n. So there it will be two different cases when m and n are different. But when both m and n are equal, so they will become only one case. Which means if we apply the same formula here, then we'll be counting one case twice. So that must be eliminated. So that's why here we are dividing this by 2. Right. So here 2 factorial, 2n factorial by, so the number of ways when both the groups are equal is given by the formula, that is 2n factorial by n factorial into n factorial into 2 factorial. So this will be the number of ways here. So coming into the next one here. So however, if 2n objects are to be divided equally between 2 persons, then the number of ways. So here what happens? So now we have already know the number of ways of dividing the 2n objects. So that is nothing but 2n factorial by n factorial into 2 factorial. Yes or no? But now after having this number of ways of dividing these two objects, we have to divide these between two persons equally. Right, so if we are dividing between two persons, it will be into 2. That means into 2 factorial. Right, so then it will be it turns out to be 2n factorial by n factorial into n factorial. So when we are distributing equally between two persons, then it will be into 2 factorial. Then the number of ways of equally distributing this divided to n objects between two persons is given to be 2n factorial divided by n factorial into n factorial here. So the same thing can be happen for 3 groups when we have 3. Right, so what is our first case which we have discussed about this division into groups? So the first one is nothing but when we have m plus n objects, different objects. So now here we are having m plus n plus p different objects. Right, so initially the division, so the number of ways of dividing into two unequal groups is given by m plus n factorial by m factorial into n factorial. Whereas now here we are having 3 different groups. So 3 different objects we are having. So now we will be dividing into 3 different unequal groups. So as it's 3, then it will be m plus n plus p factorial by m factorial into n factorial into p factor. So the same thing, but in our previous case it is 2, but now it is 3. Right. So after this, if we have equal, so all these m and n will be equal. So that will be the second case which we have discussed. So when all 3 will be equal, so here it will be m plus n plus p factorial. Initially it is m plus n plus p factorial by m factorial into n factorial into p factorial. Right. So now in this particular case, both m, n and p all will be equal. So then substitute in place of m and p also n. That is n plus n factorial divided by n factorial n factorial n factorial. That is equal to 3n factorial divided by n factorial n factorial n factorial, and in our previous case it is into 2 factorial. So now it will be into 3 factorial in the denominator. So when all the 3 will be equal, so how many are getting equal here? So that will be, that number of factorial will be divided simultaneously in the denominator. Right. So now what is the formula? When all these 3 are equal, then the number of groups that we'll be dividing here is given by 3n factorial by n factorial n factorial n factorial into 3 factorial. So now we have to equally divide these divided groups amongst 3 different persons. That division among people will be the same. So here we are dividing equally among 3 persons. So it will be into 3 factorial. Right. So this 3 factorial and 3 factorial will be getting cancelled, and we end up having the number of ways that we can equally divide among the 3 persons is nothing but 3n factorial by n factorial and n factorial. Right. So these are our division into groups. So the first we have taken for 2 groups, that is 2 objects, and second we have taken the case of 3 objects. So let's just have a recall of all these formulas once. So the first one we are having is 2 groups, that is m plus n factorial by m factorial into n factorial. So when these 2 will become equal, then it will be 2n factorial by n factorial into 2 factorial. when these are divided amongst two people equally, that means two persons equally, then it is 2n factorial by n factorial into n factorial, and this into 2 factorial, so these two will be getting cancelled. So the same case will be applicable for our 3. So that is m plus n plus p factorial by m factorial into n factorial into p factorial. So m plus n plus p factorial divided by m factorial into n factorial into p factorial. So now when these 3 will be equal, then what it happens, that is all will be same. Then it will be the next case. So 3n factorial here divided by n factorial and n factorial. So as all these 3 will equal, we have to multiply into 3 factorial in the denominator. So now the next case is we have to equally divide this amongst 3 different persons. So that is given by 3n factorial divided by n factorial into n factorial into n factorial, because into 3 factorial will be there and both the into 3 factorial in the denominator and the numerator will get cancelled, resulting this to be our number of ways so that we can divide equally among 3 different persons. Right. So now as we have seen our division into groups, so let's just do a question here. So first I'm just giving you some time so that you can analyze the question and try by your own. Take 2 to 3 minutes and then I'll just explain you the question in detail. So read the question, guys, and let me know if you face any difficulty, or else analyze it. Just understand the question and try to apply the concept that we have learned. So we have considered the case where we have 2 as well as 3. So now understand it and apply in order to answer this question. So in our concept, we are having m plus n objects. So this m plus n objects are nothing but total objects or not? Right, so here they have given in how many ways can 12 balls be divided between 2 boys. Right, so there are 12 total balls, so total objects here will be 12. And these 12 balls must be divided between 2 boys, one receiving 5 and the other 7. That means this 12 must have been divided as 5 plus 7, which means m value can be 5 and n value can be 7. That will be 5 plus 7 objects we are having in total. And these 5 plus objects, in order to divide them into two unequal groups, so what will be the number of ways? So that is nothing but 5 plus 7, that is 12 factorial divided by 5 factorial into 7 factorial. But here they are not asking us to simply divide them into two unequal groups, but after dividing that we have to divide again between two boys. So when we are distributing or dividing between two persons or two boys, it will be always into 2 factorial. So what will be the answer here? So the number of ways here is given by 12 factorial by 5 factorial into 7 factorial into 2 factorial. So now you guys might have understood why we have been divided by 2 factorial, because here our m and n are not equal. So if they are equal, then we will be dividing again with 2 factorial. Whereas in this question, the m value is 5 and n value is 7. So both m and n are not equal here. Right. So simply simplify this factorial value and let me know the answer. So comment down the answer in the comment section, guys. So simple simplification here. So let's simplify it. So 12 factorial can be written as 12 into 11 into 10 into 9 into 8 into 7 factorial. And 5 will be 5 into 4 into 3 into 2 into 1 into 7 factorial and into 2 factorial, so 2. So this 7 factorial and 7 factorial will be getting cancelled. 4 3s are 12, so 12 will get cancelled. 5 into 2, 10, so 10 will get cancelled. And we are here remained with 11 into 9 into 8 into 2. Right. So 16 into 99. So 16, so 11 into 9, 99 into 8 2s are 16. So 16 into 99 will be 4, 8, 5 and 1. So it will be 1584. So the number of ways that 12 balls be divided between two boys so that one receiving 5 and the other receiving 7 balls is given by 1584 ways. So now I hope you guys got an idea how to relate our division of groups concept into this questions and like our application part of it, because they won't be directly giving you some m objects, n objects and something like that. So it will be something like this. So where they'll be trying to form a word problem question in order to get the, like in order to make us feel tricky. So but we have to just understand the concept and so that we can just get the answer. So it's just application of it. So let's do one more question related to that and then we'll just move on to our next concept. So I hope you guys can do this. So take your time and understand the question and try to answer it. Let me check if anyone has already given the answer, guys. Not yet. I think still working on it. So just read the question. So divide 50 objects in 5 groups of size. So initially we have dealt with 2 as well as 3, but here they are dividing into 5. Of size also they have mentioned, that is 10, 10. So 10, 10, 10, 15 and 5, which means 3 are of equal size and the other 2 are different size. Which means it's a combination of our 2 cases where we have taken first case not equal condition and the second case equal size. So both will be combined in this question. So it's like both the application of both the cases. So here, what are our total objects in this given case? So total objects will be 50, guys. And the group sizes which we have to divide is one is 10 and the other is 10 and the other is 10 and the next one is 15 and 5. So these 3 of same size and the other 2 are different size. So how we will be dividing here? So it is given by, so that is our number of ways here, or the number of distributions. So total, that means 50 factorial direct divided by, so these are equal. So 10 factorial, 10 factorial and 10 factorial. As these 3 are equal, so whenever we are having equal, how we will be doing? It should be multiplied by 3 factorial. Right. And the rest here will be 15 factorial into 5 factorial. So this is our number of ways which is given by 50 factorial divided by 10 factorial whole cube into 15 factorial into 5 factorial into 3 factorial. Right. So for this same distribution, if we want to divide them amongst 5 persons. So if we want to divide among 5 persons, then how we'll be doing? So it's simple that after taking this number of ways, it should be multiplied into 5 factorial as we are dividing for 5 different persons. So that will be given by 50 factorial by 10 factorial whole cube, 15 factorial into 3 factorial, as we have to do this 5 factorial, and even in the denominator we already have this 5 factorial. These two will be getting cancelled and it will be resulting that 50 factorial by 10 factorial whole cube into 15 factorial into 3 factorial. So I'm just recreating that. If in case we must divide into, like we must divide this for 5 different persons, then it must be multiplied into 5 factorial. So this will be the thing. But whereas according to the question, they just simply asked us to just divide into 5 groups of size which they have mentioned. So this will be the answer for this question. So now I guess you might have got an idea how to apply our division into groups in order to get the answers for these typical word problem type of questions. So this is all for our division into groups. So let's move on to our next concept in our chapter, permutations and combinations. So here comes the next concept, that is circular permutations. So initially we have seen a permutations where the arrangement will be in a straight line, in a standard format. Whereas by the name itself, for the circular permutation, the arrangement of the objects will be in a circular format. Right? So the number of circular arrangements of n different objects. So initially, if we are having a line arrangement, then it will be directly n factorial when we take n at a time. Right. But whereas for a circular permutation, that is a circular arrangement of n different objects, is given by the number of linear arrangements. That means in a straight line arrangements, it will be n factorial divided by how many objects we are having. So this is the difference. So which is nothing but n factorial can be written as n into n minus 1 factorial divided by n. So n will get cancelled, which is equal to n minus 1 factorial if clockwise and anti-clockwise orders are taken as different. Right, that means here, let's take an example here. So if we are having 4 objects A, B, C, D. So according to a straight line, the arrangements can be, so A, B, C, D, D, A, B, C, C, D, something like this. So whereas in a circular arrangement, if we go from here, it will be A, B, C, D. Right. And then if we start from B, it will be B, C, D, A. And if we start from C, it will be C, D, A, B and D, A. Whereas here for circular, it will be like this. Either it go by like this or else it can be like this. Right. So that's the case where we have taken clockwise and anti-clockwise orders are taken different. So this is, so if in case I am having arrangement like this B, B and A and C. So even if I go by anti-clockwise direction or anti-clockwise direction, my second element is same. It's not different. Right. So that case we haven't discussed yet. So this case here, the formula for our circular arrangements, which is n minus 1 factorial, will be applicable when, that is, both clockwise and anti-clockwise orders are taken as different. Right, I hope you got the point here. Clockwise and anti-clockwise orders are different. So if we are having n different objects, so the number of circular permutations is simply given by n minus 1 factorial if the clockwise and anti-clockwise orders are taken as different. So the next case will be if they are same. So here you can identify the example that it can be AB if we go by anti-clockwise, and even if we go by clockwise, it's AB. There is a possibility, right? So when we have such a case, then we'll be counting twice. So that twice must be eliminated. So that's why for particular case, when both the clockwise and anti-clockwise arrangements are not different, then the number of circular arrangements of n different objects is given by n minus 1 factorial. So that 2 time count must be eliminated. So divided by 2 here. Right. So what is the formula for a circular arrangements? That is our circular permutation. So the number of circular arrangements, if both the clockwise and anti-clockwise are different, then it will be n minus 1 factorial. If they are same, then it will be n minus 1 factorial divided by 2. So that's the difference when we come and check for the clockwise. That is our circular permutations. So let's have some look over some note points here. So the number of circular permutations of n different objects taken are at a time. So in the previous case, what we have discussed? We have discussed the number of circular permutations of n different objects taken all at a time. So that's why it is n factorial, which is npn. But now in this case, the number of circular permutations of n different objects taken only are at a time. So then circular permutations is given by first in the numerator number of linear permutations, that is NPR. So how many we are taking at a time, that must be divided. So it will be divided by R. Right. So this is the first case, that is the number of circular permutations of n different objects taken R at a time is given by NPR by R when both the clockwise and anti-clockwise orders are treated as different. Right. So this will be the same NPR by R when R is selected. If clockwise and anti-clockwise are treated as different, then it must be divided by 2. That it turns out to be NPR by 2R. Same formula, guys. So in the previous one, what we have seen? N factorial by N or not. So what is this N factorial? NP N or not? That means when we have n different objects and taken all at a time, that is all the n objects at a time, that is given by npn, which is equal to n factorial. So whereas in this case we have taken only r at a time, so that's why instead of npn we'll be having here npr. So how many we have taken? N at a time, so that's divided by n. So here r at a time, so divided by r. So this is the case where both clockwise and anti-clockwise are treated as different. Whereas if they're treated as same, then it must be divided by 2 because we have to eliminate the case of repetition. So which will be npr by 2r. That's all. So just now we have already seen when we take all n at a time. So that is nothing but, so from amongst the n objects, if we have selected all n at a time, then it will be npn by n. That is nothing but n factorial by n, which is equal to n minus 1 factorial. That is, this is the case when both the clockwise and anti-clockwise are treated as different. So what happens when they are treated as same? Then it will be n minus 1 factorial by 2. Right, so here there is some mistake. So this will be the case. So you have to get an idea when same divided by 2, when it's different, no division. So we'll be leaving as it is. So these are the formulas which are related to our circular permutations. So let's have a look over a question and try to understand this circular permutation in detail. So you guys are already familiar with this linear permutation and all. So now apply those and just understand the formulas and the concept that we have learned for circular permutation and try to answer this question. So take your time. So there, if it's n factorial, for circular it will be n minus 1 factorial. So you just go by the flow by identifying that condition here. So read the question first, try to understand it and try to relate how you will be doing in general of linear arrangement and what will be the difference when it comes to the circular. So there you will be understanding the difference and then it will be easy to solve it for our circular permutation. So in general, if they haven't mentioned that both clockwise and anti-clockwise are same, so we can go by flow that we can consider them as different. Right. So if according to the question we can understand if they are same, then by that also we can go by that. We can go by the flow. So let me check if you guys have any doubts, any question in regard of this question. You can please let me know in the comment section. So far, no doubts. Okay, it's good. So if you're not getting doubts in the sense, either you're getting the concept entirely or else you're not getting anything. So try to focus and understand, guys. So there is no bad. If you have any doubts, you can let me know. I can explain you in detail. So I'll repeat 2-3 times if you're not getting understand. So no issues with that. So let's read the question first. So in how many ways can 5 Indians and 4 Englishmen be seated at a round table? So by this word you can understand that it's a circular permutation. So round table, so it will be like this, which triggers at that. So which triggers us that it will be a circular permutation here. Right. So the question is, how many ways can 5 Indians and 4 Englishmen be seated at a round table? If so, we are having 3 conditions. So the first one, they haven't mentioned any restriction. So when there is no restriction, we'll just go by the general arrangement. So if it's a linear arrangement, then it will be 9 factorial. Whereas here it's a circular permutation. So first we have to find the total. That will be 5 plus 4, which is equal to 9. So total 9 persons we are having here, right? So for this 9 persons, we have to arrange them. We have to make them seated at a round table without any restriction. So it will be 9. So it will be N 9P 9 by 9. That is equal to 9 factorial by 9, which is equal to 9 into 8 factorial by 9 equal to 8 factorial, which is nothing but our direct formula of permutation of circular permutation, which is n minus 1 factorial. So here our n is 9 total persons here, which implies 9 minus 1 factorial equal to 8 factorial. So without any restriction, we can arrange these 5 Indians and 4 Englishmen be seated at a round table is given by 8 factorial. Right. So as I explained you the first part of it, so I think now you guys got an idea how to deal with it. So can you give it a try for second and third and let me know the answer? So let's go by the second one. The number of ways so that all the 4 Englishmen sit together. So we have already seen in our regular linear permutation, when we talk about sit together, they must be taken as a single block. So all these 4 Englishmen, that is E1, E2, E3 and E4. So let them take as a single box. And the other, we are having 5 Indians. So I1, I2. So how many we are having? 5 plus 1, 6. So in general, it should be for linear arrangement, it should be 6 factorial. Whereas here it's a circular. So it will be 6 minus 1 factorial. And these 4 can be rearranged amongst themselves. That is, how many are there here? 4. So it will be 4 factorial, which means 6 minus 1 will be 5 factorial into 4 factorial. So the number of ways so that all the 4 Englishmen sit together is given by 5 factorial into 4 factorial. So here it will be 5 factorial into 4 factorial. So coming to the last one, all 4 Englishmen don't sit together. So just now we have seen the number of ways so that these 4 Englishmen sit together. So the next one, the next question is, they are talking about don't sit together. So if we eliminate the sit together from our total arrangements, then it will be obviously equal to not sit together. That means our total arrangement without any restriction will be 8 factorial. So amongst this 8 factorial, if we eliminate the arrangement, that is the ways, if the 4 Englishmen sit together, that means 5 factorial into 4 factorial. Right. So that will be equal to our number of arrangements, that is all the 4 Englishmen don't sit together. So there is no need to find a different way of doing it. So simple way of solving and getting the answer so that all 4 Englishmen don't sit together is subtract the sit together ways from our all number of ways. That is here 8 factorial minus 5 factorial into 4 factorial. So this will be the final answer here. Right. So let's move on to the next one. So here comes the next question in regard of our circular permutation. So just now we have dealt a question. So now you might have got an idea how to deal and crack the questions related to this circular permutations. So now take your time and read this question and try to answer this question related to the circular permutation here. So this question, I hope you guys can easily solve this. So just take a look. So here you have to identify, they are talking about a necklace with pearls. So same concept, just now how we have solved it. So let's read the question here. So consider 21 different pearls on a necklace. How many ways can the pearls be placed in this necklace such that 3 pearls always remain together? So we'll just keep these 3 pearls together. So if we take these 3 pearls, how many will be remaining here? So 18, 19, 20, 21. So 18 will be remaining. So this will be 1 and the remaining will be 18. That means 18 plus 1 will be 19 total. So now according to a necklace. So if this is a necklace will be in this shape or not, which is a circular arrangement. That means our circular permutation. So that will be here 19 minus 1 factorial. And these 3 amongst themselves, they can be arranged. So it will be 3 factorial. As this is a necklace, we cannot specify that the clockwise and anti-clockwise are different. So that's why divided by 2. So now it will be 19 minus 1 factorial, which is 8 factorial, into 3 factorial will be 6, and 2 here, which is cancelled by 3. That means 3 into 18 factorial will be the number of ways here, so that we can arrange these 3 specific pearls always remain together. That means 18 factorial into 3. Right, so the only thing we have to get here is when it's a necklace, we cannot predict that both the clockwise and anti-clockwise are different. So let's move on, guys, to the next one. So the next concept we are going to discuss here is sum of numbers. Right, so let's read out the thing here. So for given n different digits, that is a1, a2, a3 and so on, an. So here we are having some n digits. So let us take 1, 2, 3 like this. So 3. So if we are having these 3 digits, the sum of the digits in the units place of all the numbers formed. So with these 3 numbers, 3 digits, we can form 3-digit number, 2-digit number and single-digit number. Yes or no? So once we have 3-digit number, 2-digit numbers and single-digit number, all the units place sum will be what? So that's what they are asking. So digits in the units place all the numbers. So not only the number 1, 2, 3. So using this 1, 2, 3 digits, we can have a 3-digit number for suppose 123 and 213 or 312 or 321. So likewise, we can form different 3-digit numbers and we can even form 2-digit number and single-digit number also. Right. So after forming the 3-digit number, because they are talking about 3 digits, so we'll be considering the 3-digit number. So in this 3-digit number, we have to find, once we have formed all the different possible 3-digit numbers here, we have to add the digits which are placed in the units place. So that sum they are going to ask here. So that is the sum they are asking here, sum of the digits which are placed in the units place of the numbers. So that is directly given by, so sum of the digits which are given here, that means a1, a2, a3 and so on, some n digits. So sum of all these digits into n minus 1 factorial. So this will be the sum of the units place of all the digits. So sum of digits which are placed in the units place, which are the numbers formed using the n digits and different digits here. So the same thing, sum of the total numbers. So previous one only we have taken the unit digits, sum of only unit digits. But here we are taking sum of all the total numbers which can be formed. So this is also be the same typical format. That means, so if we take 1, 2, 3, so the possible 3-digit numbers 123, 213, 321, something like this. So likewise will be having, so the sum of 3-digit, sum of the total numbers will be this total they are asking. So 9, 10, so 9. So likewise this sum they are talking about, all the entire numbers. Not only digits here. Here in this case, we are doing the sum of the total numbers. So that is given by the same typical thing, sum of the digits first into n minus factorial. The second, same as the previous one. There will be one new concept, new addition here, that is, will be doing this 1, 1, 1 until n times. How many n we are having? So for suppose I am taking 1, 2, 3. Then it will be 1 plus 2 plus 3 into 3 minus 1 factorial into 3 numbers I am having, that is 3 digits I am having. So it will be 1, 1, 1, 3 times. So 3 plus 2, 5 plus 1, 6. So it will be 6 into 3 minus 1 factorial 2. So it will be 2 into 111. So it will be, the answer for these 3 digits will be the sum of all the digits, the sum of all the total numbers which can be formed using the given 3 digits 1, 2, 3 will be equal to 12 into 111. So this will be my answer. So it's as simple as that. So the first one will be only the sum of the unit digit, but here sum of the total numbers. So let's do a question. So before getting into the question, we'll just discuss the next concept also. Or else we'll just get into the question and we can discuss this factor of natural numbers in our next session, hopefully. So here comes the question. So first we'll just do this question. So just now I'll just recall the concept. For unit digit sum, it will be a1 plus a2 plus and so on an into n minus 1 factorial. Whereas sum of all numbers, so here not digits, it's the numbers, is given by a1 plus, a2 plus, and so on an into n minus 1 factorial into 1 will be n times. So n will be the total number of digits. So total number of digits given. So this is our concept of sum of numbers. So here we are having the first question. So let's do this question. Find the sum of all 4-digit numbers. So only 4-digit numbers formed using the digits. So here they have given 4 digits. So you have to find the sum of all 4-digit numbers. So they are not talking about units place. They are talking about here the 4-digit number. So it's a complete number. Sum of the complete number. So quickly do that and let me know the answer. I'm just arranging the formulas. Okay. So find the sum of all 4-digit numbers formed using the digits. So this will be our second formula in the sum of numbers which you have discussed. So sum of digits. So here what are the digits which they have given? 1, 2, 4 and 6. So what is the formula here? So sum will be equal to, so a1 plus, a2 plus and so on until an into n minus 1 factorial into 1, 1, 1 until n times. Right. So here the sum of the digits. So what are the digits here given? So 1 plus 2 plus 4 plus 6. And how many digits? So 4. That means 4 minus 1 factorial. So 1 must be repeated in 4 times because we are having 4 digits. So 6 plus 4, 10, 12, 13. So 13 into 3 minus 1, sorry 4 minus 1, 3 factorial, that is 3 into 2 into 1, 1, 1, 1. So let's do the multiplication here. I'm just using the calculator here. So 13 into 3 into 2, 6 into 4, 1. So which is 13 into 6 will be 78. That we already know, into will be equal to 1, 1, 1, 1. That is equal to 86,658. So this will be the sum of the all 4-digit numbers which are formed using the following digits 1, 2, 4 and 6. So this is how we'll just use our formula which we have discussed for our sum of numbers in order to get the answer. Right, so that's all for today guys. So in today's session we just discussed about our division into groups as well as the circular permutation, and we have even started with our sum of numbers, and we are having few more concepts like factor of natural number and prime numbers as well as the multinomial theorem and all. So those we'll be going to cover in next session of permutations and combinations. So next session will be most probably the last session of our permutations and combinations chapter. So if you have any doubts in this chapter or in this today's session, you can get back to me and you can ask me questions anytime if possible in our next session also, no issue. So but just go through the session once again and let me know if you have any doubts. So that's all for today guys. We'll just meet in our next session of permutations and combinations. Thank you.